Example 4. Find the derivative of f of x for f of x equals the square root of x. Then find the slopes of the graph at f at points 1, 1 and 4, 2. Discuss the behavior of f at 0, 0. Also, I added to this, we're going to find the equation to each of these tangent lines. So first of all, we have to start with finding the derivative. So we know the definition of the derivative is the limit of f of x plus delta x minus f of x all over delta x as delta x goes to 0. So that's something you're definitely going to want to memorize. Next, we need to find f of x plus delta x, and then we can substitute it in here into the definition of our derivative. So we already know that f of x is the square root of x, so f of x plus delta x would be the square root of x plus delta x. So now we can substitute here. So we can write this as f prime of x, which is the derivative of f of x, equals the limit of f of x plus delta x, that's going to be the square root of x plus delta x, minus f of x, which would be the square root of x, all over delta x, as delta x approaches 0. Now, unfortunately, right now we can't evaluate the limit, because if we did direct substitution, look what would happen to the denominator. That would be 0, which would make this function undefined. So we can't do that. So we need to algebraically manipulate this. To do this, I'm going to multiply the numerator and the denominator by the conjugate. So hopefully you remember what the conjugate is from college algebra, but the conjugate of the square root of x plus delta x minus the square root of x is going to be the square root of x plus delta x plus the square root of x. And we're going to multiply that by the numerator and the denominator. Okay? So when we multiply through here by the conjugate, we get the derivative of f of x equals the limit. The square root of x plus delta x times the square root of x plus delta x would be x plus delta x. Okay? Notice when you multiply by the conjugate here, okay, next you're going to get positive the square root of x times the square root of x plus delta x. And then the next term would be, when you multiply these together, it would be negative the square root of x. So you're going to have the opposite. So the two middle terms are going to cancel out. So I'm not going to write those down. And then you're going to have to multiply negative square root of x times positive square roots of x. So that's going to be negative x. All over the denominator, which I'm not going to multiply it through. I'm just going to write it as a multiplication problem. So it's going to be delta x times the square root of x plus delta x plus the square root of x as delta x goes to 0. Now let's simplify this some more. The derivative of f of x equals the limit. The numerator, notice that the x's cancel out, x minus x, that would be 0. And then also you have delta x divided by delta x, that's going to be 1. So in the numerator I'm going to be left with 1 In the denominator, I'm going to be left with the square root of x plus delta x plus the square root of x as delta x goes to 0. Now we can evaluate our limit. So now, as delta x goes to 0, in the numerator you're going to have 1, the denominator you're going to have the square root of x plus the square root of x, because the delta x goes to 0, so this is going to be 2 square roots of x. Okay, so there's my derivative. Remember that this is equal to the slope of the tangent line. Okay? And so we want to find the slope of the tangent line. Get some room here. We want to find the slope of the tangent line, which would be f prime, when x is equal to 1. So I would plug that into this function here. This would be 1 over 2 times the square root of 1, which would be equal to 1/2. So for this particular function, the square root function, when x is 1, the slope is going to be 1/2. Now we also want to find the equation of the line at that particular point. So at that particular point, the point is 1, 1, which is x, y. This is just m, that's the slope. So if we use y equals mx plus b, we can come up with the equation of the line that goes through this point when the slope is 1/2. In other words, we're going to find the y-intercept. So y is 1, m is 1/2, x is 1. We're going to use all that information to find b. Here you can see if I would subtract 1/2 from each side, I'm going to get 1/2 equals b. So the equation of the line here, of the tangent line, would be y equals 1/2 x plus 1/2, which is the y-intercept. Okay. Next, we want to do the same thing at the given point 4, 2. So again, the slope of the tangent line would be equal to f prime. This time it would be 4, which is equal to 1 over 2 times the square root of 4, which would be equal to 1 over 4, because the square root of 4 is 2. 2 times 2 is 4. Okay? And again, the given point here was 4, 2. So now we want to come up with the equation of the line, y equals mx plus b. So let's see, y equals mx plus b. Y is 2. The slope for this at this point here is 1/4. X is 4 equals b. This would end up being 1. So I'll subtract 1 from each side. I'm going to get 1 equals b. So the equation of the tangent line at this particular point would be y equals 1/4 x plus b, which is 1. Finally, let's look at what the slope of the tangent line would be, f prime at 0, 0. So x would be 0. You would get 1 over 2 times the square root of 0, so this would be 1 over 0, and the slope would be undefined. Okay, since the slope is undefined there, we can't really find the slope. It's just the slope is undefined. And we can't come up with the equation of the line. Okay? Hopefully that makes sense, because if you think about the graph of the function, the square root of x, Okay. Okay, when you plug 0 into this function, you get 0. When you plug 1 into this function, you get 1. And then if you plug 2, you get the square root of 2, which is some decimal. So I'm going to go to 4 next, because the square root of 4 is 2. So the square root function looks like this. So you can see here, when x is 0, for this function, you can't really draw a tangent line here, because the slope could be this way, the slope could be that way, the slope could be this way. That's why we call it undefined. Where all of these other points, we can draw a tangent line that goes through this specific point, okay, and doesn't intersect anywhere else.